Preview test. Okay. Yeah. So which question? Last question.
Yes, sir.
Question number 6. What it says, two blocks A and B of masses 1 kg. A is 1 kg, B is 3 kg, are kept on a table as shown in the figure. The coefficient of friction between A and B is 0.2, and between B and the surface of the table is also 0.2. The maximum force F that can be applied on B horizontally so that the block A does not slide over the block B is. So guys, tell me the information. There is this block. This is 3 kg, right? And this is 1 kg, correct? And there is a force F is being applied on 3 kg block. And here is the coefficient of friction 0.2. Here is also 0.2, correct? Now, tell me, if I am drawing the free body diagram of this block, so F will be in this direction and friction will be in this direction, correct?
Yes, sir.
Any doubt here?
No, sir.
No. And you know that there will be no one normal acting on this block due to this 1 kg block, correct? How much it will be? 10 Newton, right? Correct, no guys?
Yes, sir. Yes, sir.
Mg. That much of normal will be acting on this block. Okay, all right. And if I see what they are saying is these, if the block 1 kg is not sliding on 3 kg, that means these both blocks are moving together, right? You're getting me? If these two blocks, like this block 1 kg is not sliding on B, that means these two blocks are moving together, correct? With same acceleration.
Yes, sir.
Any doubt in that? No doubt, correct? So that means I can say that, well, these two blocks are my system and the force acting on this system is F. So what will be the opposing force? The friction, correct? Supporting force is F minus opposing force is small f is equal to mass into acceleration. Now the mass is 4 because both are moving together and into acceleration A, correct?
Yes, sir.
No doubt here, right? Now, why my pen is not working? Okay, so 4 into A. Now tell me. So if I see 1 kg block free body diagram, what like which force is responsible for this 1 kg to move, guys? Why that 1 kg is moving? First you tell me. There is no force acting on it, right? You are applying F on 3 kg. Why it is moving? Because friction is supporting it to move. Understood?
Yes, sir. Yes, sir.
So that means we know that the acceleration is A and the net force on this block is only friction. There is no other force acting on this 1 kg. So directly I can write F equal to ma here. So F is how much? 0.2 mu into normal will be on that, it will be 10, correct? Is equal to mass is 1 kg into A. So from here you got A is equal to 2 meter per second square, correct? So F will be equal minus F is equal to 4 into A we got already 2, that is 8, correct? Here till here any doubt?
No, sir.
No. Now what is asking in the question? The maximum force F that can be applied on B horizontally so that the block A does not slide over the block B is. See what is the maximum force they are asking. So that will be F is equal to 8 plus F, correct? So it will be 8 plus F will be how much, guys? This F will be how much? it will be this 4 kg sum, 4 into G, that is 40 into 0.2, correct? So that will be how much? 8. That will be 16 Newton. Correct. Now, how I can say this is the maximum force? Correct. So, because that is the maximum value of F, right? We know that the F can vary between 0 to mu times N. Correct. So, if I'm keeping the friction's maximum value, that means this F is also maximum. So, the answer is 16 Newton. Understood?
Yes, sir.
It's a good question. What is the answer given in the exam? A only, yeah. So A is the correct answer, 16 Newton. Please note down. If you have not understood, tell me, I will explain once again. If you have understood, then no problem. Samhita understood?
Yes, sir.
You, Shreya?
Yes, sir.
Okay. Xavier is joined. Hi, Xavier. Xavier, are you there? Are you sleeping?
Hello, sir. Sir, give me 2 minutes. I'm in the road. I'll just.
Okay, okay. Okay, आराम से, आराम से.
Yes, sir.
Okay, guys. Any other questions that you simply got answer but you didn't get clarity? Anything like that?
No, sir.
Nothing. Everything is clear. Everything is clear, right?
Yes, sir.
Okay. Now we'll see some pulley questions. Pulley string concept. Okay. Now, so no, sometimes what happens is they will give something like this. Okay. Let's say I'll give you 2 pulleys and there is one more pulley here. There is a string going like this, and like this, like this. Let them give any number of pulleys they want to give. Okay. Let's say there is one mass here, M1, there is another mass, M2, and here there is other mass, M3, and then there is a mass, M4. Okay. So then they will ask you what is the acceleration of each mass. Like that, they will ask the question. Okay. First, what you have to do is you start from one string. Okay. One string. Let us say, I will say that the tension in this string is T. Okay. And this you check which is same string. This is the same string, right? So in this also the tension will be T. Then what you have to do is they have to tell in the question the pulleys are massless. Ideally, if they don't say anything, that means the pulleys are massless, correct? So now I want to find what is the tension here. So let's say there the tension is T1, correct? So if this pulley is massless, then the acceleration of the pulley should be equal to 0, right? Otherwise, you can say not 0. Net force on the pulley is 0. Net force will be what? T1 is the supporting force. So tension on the pulley will be acting in the opposite direction, right? So T1 is the supporting force for the pulley and T plus T is the opposing force. This is the net force on the pulley. This should be equal to mass into acceleration. Since mass is 0, the 0 into acceleration will be 0. So from here you will get to know that T1 is equal to 2T. Any doubt here?
No, sir.
Yeah. So you can immediately say here, if it is T here, if it is T here, 2T here, you can say. So if it 2T here, then again the same string is going. So here also the tension is 2T. Okay. So you can you have to show like this for one pulley. It is always pulling force. Okay. So you have to show like that. So again, this is same string, guys. So here also 2T. That means here how much? Tell me, anyone? How much will be tension here? Guys,
40.
40. Yeah. Why? Because the supporting force is 40, then opposing force has to be 40 because the net force is 0 on the pulley. If it is 2T here, what will be the tension here, Samhita?
Sir, 40.
Very good. So what will be tension here, Shreyuta?
40.
Very good. What will be the tension here, Samhita?
Sir, 40.
Very good. Okay, now if they ask you to find the relation between accelerations of each, let us say the acceleration of this is a1, okay, and you know that the acceleration of this and this has to be same, otherwise the string will break. They are connected to same string, right? The acceleration should be same. If this is moving with up with a1, this has to move down with a1, okay. And then so let's say this pulley is there, right? So this point will also move right up. Let's say it has an acceleration a2. You assume any direction, otherwise you beginning, if you don't know anything, assume all upward only, okay. A1, this is a2, and then this mass is moving with a3, okay, and then let's say this mass is moving with a4. Is there anything that can move? This pulley can also move, right? Correct, because it is free. Otherwise I'll fix it. Let's say this pulley is not moving, this is fixed. Now after assigning all the accelerations, you have to do that summation of t dot a equal to 0, okay. So this you have to do. See, first mass, what is t is also positive, a is also positive, you write t into a1. For this mass, t is also positive, a is also positive, you write t into a1. For this pulley, the force is how much here? This pulley is pulled by how much? 2T, and opposed by 2T, that net tension is 0. So you can write tension, net tension on the body is 0. So you can just write 0 plus, then this mass 40 into A3, correct? Plus finally this mass, that is 2T into A4. This should be equal to 0. This is a shortcut you have to use. From here, t gets cancelled out. So you can say that a1 plus 4a3 plus 2a4 equal to 0. Correct, guys? From here, you can say 2a1 plus 4a3 plus 2a4 equal to 0. This will be your answer. This is the relation between all of them. Okay? Any doubt?
No, sir.
No. Okay, all right. Note it down. I will change the slide. Once done, let me know. Done, guys? Hello.
Done, sir.
If you don't be quiet, okay? Okay, let us do one. JEE question. Okay, it's a good question. But I'm not getting a message. Okay, let us do one question. Some good questions we'll do. Let us say there is a diagram like this, and there is a string going like this. There's a pulley. Okay, and then the string is going like this, and there is one more pulley here, and then it is coming like this, and there is one more pulley here, and then it is finally connected to the block again, and this pulley is also fixed. Okay, and then we have also fixed these pulleys also to a ceiling. Okay, so well, so this is not connected here. Okay, let me just erase this one. Yeah, there is a man here, okay, who is pulling this crazy guy, and yeah, so that's it in the question. The question says a boy of mass 4 kg is standing on a piece of wood having mass 5 kg. So this has 5 kg mass, the boy has 4 kg mass. Okay, is standing having mass 5 kg. If the coefficient of friction between the wood and the floor is 0.5, here the coefficient of friction is 0.5. Okay, 0.5. The maximum force that the boy can exert on the rope so that the piece of wood does not move from its place is dash. G is equal to 10 meter per second square. Okay, so let us do together. Please cooperate with me. Let us say the tension in this string is T. Okay, so in here, what will be the tension, Shreyuta? Samhita?
T, sir.
T. What will be the tension here?
T.
T. Always write like this. Okay, away from the pulleys you have to write. And then what will be the tension here? T. T, right?
Yes, sir.
Okay. So now tell me, what will be if this block should not move? That means what is the condition? What is the force acting on this block? Which force can move this block in this direction?
Friction.
Friction will try to stop it, no? Friction is acting like this. So that friction value goes from 0 to mu times n, correct? If my force is greater than this or equal to this, then it will just start moving. So what should be the my maximum T? That will be equal to the friction value, correct?
Yes,
Correct, no
sir.
guys? Yeah. So you guys tell me now what I should do. So if I see this boy and this block as my system, then what is the mg acting downwards? 5 plus 4 kg, that is 90, correct? And
Yeah.
from ground there is a normal reaction n. So, but again, there is one more thing. Can you observe that is acting on this block in vertical direction? What is that? Tension, right? Because finally this string is connected to this block, right? And there is in vertical direction, people forget to consider this T. This T is acting on this block both in horizontal and vertical direction, remember that. So that is, there is one tension also acting. So my equation will be tension plus normal should be equal to 90. This is my first equation, correct?
Yes, sir.
And we know that this tension should be equal to friction, right? If you just want to move this, so from this it is mu into n, correct? So from here you can write mu is 0 point, how much is given? 0.5. times 90 minus T I can write, no? Because I want normal mu into N. Correct? Solve this. T equal to 0.5 times 90 minus T. If you solve this, you are going to get 1.5 T equal to 45. So from here you are going to get T is equal to 30. Okay, this much force minimum you have to apply. Good question. Clear? Should not miss this tension.
Yes, sir.
Noted?
Yes, sir.
Okay, let us go ahead. Let us now talk about spring force. Guys, for any spring, if I'm just buying it from shop, right, there will be no any stretching or any compression. It will be having its own natural length, correct? But when I pull it little bit from both sides, it will start either you can either stretch it by applying force in this direction, or you can compress it by applying force in this direction, right? Correct, guys? So there will be, then what
Yes, sir.
this spring will, in this case, it will try to go back, right? F spring. Here in this case, the spring will try to push it back, F spring. Correct? And the value of the spring force is given by K times X. Okay? The value of the spring force is given by K times X. It is like tension only. Okay? Note it down. Noted?
Yes, sir.
Yeah. So let us consider a simple case. Let's say there is a spring and a mass M. So when you connect and if you just release it, what happens? This spring will be having some stretchings, right? So if it is having stretching, then it will try to go back. This will be the FSP. And there is mg acting downward, right? And if this block is at rest, that means the supporting force and the opposing force should be equal to same, right? Now, what is the spring force? I said K times X, where K is the spring constant. This is mg, correct? Now, how much will be the stretching? Mg by K. Mg by K. Understood?
Yes, sir.
Okay. Let us do, there is one beautiful question I have recently seen. Where is it? Let me just saved it for you guys. Yeah. So there is one question. What happened? Yeah. So the question is like this. So they have given there is a mass M1 Okay. And now there is a spring and there is one more mass M2. Okay. And we have kept it on a support. Let's say there is a support table or something like that. And the G is acting downwards. Okay. The question is, the system of two weights with masses M1 and M2 are connected with a weightless spring as shown. The system is resting on a support. The support is quickly removed. The acceleration of each of the weights right after the support is removed are. The question is, what is the acceleration? What is the accelerations of M1 and M2 just after removing the support? Just after removing the support. This is the question. Very good question it is. Okay, many people do it wrong. First we will see, before removing the support, what is the free body diagram. Yes, Shreyuta, you tell one free body diagram. Samhita, you tell one free body diagram. Xavier, are you there? Xavier, I think is not. Okay, so tell me first, Shreyuta, tell me the free body diagram of M1. What are the forces acting on this with direction?
M1G is acting downwards, and the spring force is also acting downwards.
No, it will be upwards, no? Because when you keep the mass on the spring, now it has compressed. Now it will try to come back, right?
Yes, sir.
Always remember that the spring tries to come back to its natural length. Okay. Yeah. So Kx will be upwards. What other forces? Any other force you feel? Nothing, right? Just tell nothing. Shreta.
Yeah, I think there's no other force.
Yeah. So tell me what should be the equation. What should be the relation between these two?
M1G is equal to Kx.
Why so? Because the block is not at all moving. Right?
Yes,
It is
sir.
simply resting. Now come to Miss Samhita, madam. Yes, madam. Tell me.
So M2G downwards, sir.
Okay. Then
Normal upwards.
normal upwards. Then
Spring force. No, sir. I think that's it.
अरे क्यों? Spring force is not there.
Sir, it's acting on M1. No, sir.
Why not on M2? It will act on both.
Yes, sir.
Then tell me with direction. You tell me.
I guess upwards only. Sir.
Why it will be upwards? Imagine I will give you a spring and you are pressing it with your both hands. Now you are telling that on one hand it is in other direction, on one hand it is in other direction.
No, sir. Downwards, sir. It opposes
Yes.
from both sides. I understand.
Yeah, exactly. Imagine it like M1, M2 are your hands. So
Yes,
now
sir.
the spring is putting force on your hand downward or upward?
Downwards.
Then, so tell me the equation.
N is equals to M2G minus Kx.
N is equal to,
M2G minus Kx.
I will hit you now.
Plus Kx.
You were sleeping before class?
No,
Tell
sir.
me the truth.
No, sir.
Then why are you saying minus? Okay, so this is the situation before removing the support, right? Okay, now we'll talk about what they are asking. Once we remove the support, with what acceleration M1 and M2 will move. They are asking just after removing the support. After long time, what happens? We don't want to care. Okay, now tell me guys, after support is removed, okay, tell me, once you remove the support, what happens? Which force will don't come into picture? Shreya, which force will not come into picture? Once you remove the support, what happens? Which force will go back?
Spring force.
Spring is there. No, where spring is not going anywhere. I'm asking, see, you have written there are many forces. You have written Kx, M1G, M2G, normal. Which force will not come into picture if there is no support? Samita.
Sir, is M1 attached to the ceiling or it's just
No, everything is in air. Did I attach? Am I showing any string there? Don't think too much. Just tell me which force will not come into the picture if I remove this up. Just think, if there is support, which force is coming? Because of
right?
support. Yeah,
Normal to zero?
normal. Yeah, normal becomes.
Zero.
If normal becomes 0, is there anything related to this guy, M1? Is normal related to M1?
Yes, sir.
No, it is not. Anywhere coming in within M1, that normal?
No, sir. I
No.
mean, I thought in
That
the
means,
second equation.
yeah, in second equation it will come. But in first equation it will not. That means M1, there will be nothing change for M1 if you remove this support. So just after you remove the support, acceleration of M1 will be 0. Okay? For that moment only. After it will start falling down with G. So what about this guy, M2? What do you think? What will be its acceleration? What is the force acting on M2 now? Once the normal becomes 0.
Minus kx.
Only that? M2G is also there. No, see, just see from equation, you put n equal to 0. Why we said n is equal to M2G plus kx? Because the net force is n minus M2G plus kx. This is net force equal to mass into acceleration. Acceleration is 0. That's why we said this 0 and this equal to this. Correct?
Yes, sir.
Now n became 0. Then what is the net force remained?
M2G
Plus
kx.
k. So
Yes.
now the force on M2 is M2G plus k. Simple, you have to think. Right? So if I divide it by its mass, I will get the acceleration. Now you guys know that so what is that? Kx equal to M1G, right? Put it here. So it will be M1 plus M2 times G divided by M2. This will be my acceleration of 2. Simple, right? Once you remove the support, only supporting force is there. M2G is also acting downwards. Kx is also acting downwards. So the net force on the M2 will be M2G plus Kx. So that divided by mass M2 is acceleration of 2. Understood?
Yes, sir.
Note it down carefully and solve it by yourself. First, before removing support, after removing support, and see if you are stuck in anywhere. And if you feel like anywhere you have doubt, ask me. I'll give you 2 minutes.
Sir, can you tell me the acceleration part after removing the block, after removing the support of first mass?
Yeah, so you think again. I will explain. Okay, think again. Everything is written.
Yes, sir.
Yes, guys. You got it, Samita, or shall I explain?
Can you explain it?
Okay, no problem. I'll explain. But don't put doubts in your mind. See, initially this M1 was like this, and there was the spring like this, and then we had M2, correct?
Yes, sir.
There was a support. Now, I said that, well, if I draw the free body diagram of M1, so it is M1G, and the spring force is Kx, correct?
Yes, sir.
So, since this block M1 is not moving, I can say M1G is equal to Kx, correct? And then once you remove the support, for block 2, what we said, M2G was downwards, Kx was downwards, normal was upwards. So upwards is equal to downwards, Kx plus M2G. Now, once just after, you have to think it's that very little time, just after you remove, what is happening. So just after removing, N is going to 0, correct? And before removing support also, after removing support also, normal has nothing to do with M1, because in the equation nowhere normal is coming. So that's why there won't be any change in M1's equation. It will remain M1G equal to Kx for the little time just after removing the support. That's why this block will not move at all. So acceleration of that block M1 will become 0. Now you understood?
Yes, sir.
Shrita, you are clear?
Yes, sir.
Xavier is not there. Okay. Okay. So you guys understood now spring springs also. Okay. This is the extreme hard level they can ask in the exam. Okay. Questions like this, which involves basic understanding, basic proper understanding. Okay. Apart from that, you can just solve equations and get the answers. Very simple job. Okay. So I think I covered most of the Newton's laws of motion. You guys are practicing questions based on Newton's laws of motion?
Yes, sir.
So you guys are able to solve? Yeah.
Yes, sir. I'm able to solve most of them.
Okay, so all right. There is one question, okay, kinematics based question. I will ask you. You please give one attempt and give me the answers. Beautiful question. If you get it properly, it will be great. There is one particle, okay, which is moving with 8 meter per second, and there is one acceleration acting like this, which is 2 meter per second square. Okay. So here mass is not given, so should not consider gravity, anything, nothing. Only this much is given. Okay. And this angle is 120 degree. Okay, guys. Now the figure shows the velocity and acceleration of particle at the moment t equal to 0. This is a situation. Now, the first question is the instant of time when the speed of the particle is 8 meter per second again. When will now see at this instant the particle is moving with 8 meter per second. You have to tell me after what time this particle will gain the same velocity 8 meter per second. At what time this particle gains speed of 8 meter per second again? Tell me. Just give an attempt, and if you are not able to understand, just let me know. Shreyata, are you able to solve?
I'm trying, sir.
Samhita,
Thanks.
try. I'll give you a small hint, okay? The small hint is this is a projectile motion only. In which angle you are seeing, that is important.
So is it 6 seconds?
Close but not correct. What did you do? Who told the answer? Shreyata or Samhita?
Samhita, sir.
What did you do?
Sir, I did the resultant for
This is acceleration. What resultant you did? This is velocity. Let us see what Shreyuta gets. Shreyuta, any answer?
Sir, I'm not sure how to do the question.
Okay. See, one more hint I will give. See, this, if I draw perpendicular, this is 90-degree, right? Correct?
sir. If that's the case, I got 2 root 21s.
No, no. Still wrong. This is 90-degree, this is 30-degree, correct?
Yes, sir.
Just rotate it by 30-degree. If you rotate it by 30-degree, it will become like this, right? 8 meters per second. And this acceleration will becomes like this. This you have rotated by 30-degree. Correct? This
Yes,
you
sir.
understood or not? Yes. Now instead of gravity, there is only 2. Instead of 10, there is 2. Now solve it. When will it get 8 meters per second again? In projectile, what we do? We do components first, right? This component will be how much? 4 root 3. This will be 4. So I told you, right? This will be a projectile.
Sir, does it take 4 seconds?
This will hit the ground with 8 only. That means they are asking what is the time of flight. See how questions can be made. Yeah, so to go up, it will take 2 seconds because it is decreasing with 2 meters per second square. So in 1 second, it will go to 2, then it will go to 0 in 4 seconds. Sorry, 2 seconds. So 2 seconds here, 2 seconds here. 4 seconds is the answer. Samhita, understood or not?
Yes, sir.
Now tell me, the instant of time at which the acceleration and velocity vector of the particle are mutually perpendicular is? When will be the acceleration and velocity perpendicular?
At t is equal to 2?
Exactly. Because at topmost point we have only this velocity and acceleration is acting like this, so 90 degree. Very good. Now tell me, the magnitude of displacement of the particle in time interval t is equal to 0 to 4 seconds. They're asking what will be its displacement in 4 seconds. That means they're asking what? Range. What is the answer?
4 root
8 root 3?
8 root
Hey, still
16 root 3, sir.
Why are you hurrying? Tell me the correct answer. No. So 4 root 3 into total time is 4. 16 root 3. Now it is easy, but you have to think this how you can convert it into projectile. That was the task here. That is needed. That will come only when you practice more questions. You enjoyed this question?
Yes, sir.
Two questions we did which are very hard, okay? Though the calculation is in such questions only they'll ask in JEE advanced type of exams. Calculations will be less, but the thinking process, the thought process will be great. Please make it star for both the questions and put it in your All right. So today that's it. Okay. So we'll start new chapter tomorrow. So please practice more questions. You want one more exam on this chapter?
Okay, sir.
Kinematics plus Newton's laws of motion.
Yeah, sir, that's fine.
So shall I keep it like 1 hour, 30 questions like that?
Yes.
Let us see. So 5-6 questions you guys are scoring well. I want to see if I give more questions, how you will perform. Time is also important. If you're not understanding question, just leave it. Don't attend. You have to attempt those. That strategy I did not share you how to attend the exam. See, first what you have to do is, first 5 minutes what you have to do. 5 minutes or 2 minutes, whatever. Read all questions. Read all. See, if you follow this strategy, you will score maximum. Read all questions, then try note down. Just after reading, you will get to know I can solve this easily. Note down. Let's say I have 1 to 10 questions. Okay, 10 questions are there. Well, one I read. Oh, okay, it's very easy. I will note it down in my book. 2, okay, this is easy, but I feel there is a lot of calculation. I will leave it. Okay. Third question easy again. You note it. Fourth easy, note it. Fifth easy, note it. Sixth, I'm not understanding. I will leave it. Okay, but second question you said it is easy, but with more calculation you make it star. We'll see it at the end. Then sixth question easy. Seventh easy. Eighth I'm not understanding. Leave it. Ninth I'm not understanding. Leave it. 10th is easy. So now this analysis you have done in 3 to 4 minutes or 2 minutes, 5 minutes, whatever. Once this is done, I will start solving one by one. 1 is done, 3 is done, 4 is done, 5 is done, 6 is done, 7 is done, 10 is done. Now I will come to this more calculation question. 2, I will give some calculations and I will done. So then you have to spend time on which questions, 9th question and 8th question, which you have not understood. Try to understand it. If you are understanding, solve it. Otherwise, you leave it. Starting only if you see these questions, there may be possibility that first question only I'll give difficult. You should not spend what happens, you spend time but you are not getting the answer also, time is also gone. You won't be get time to solve these easy questions. All have same marks. Correct? Understood?
Yes, sir.
Will you follow this strategy throughout your exams?
Yes, sir.
Okay, so that's it for today. So I'll see you in the next okay, so then I will upload one question paper for you guys. You attend it. So tomorrow I will make the timing from 10 to or morning 6 to evening 6 p.m. You attend in between. Before that, revise your notes, revise concepts, and then attend the exam. Okay, guys?
Okay, sir.
Yeah, Mr. Xavier, are you there? He's replying in chat. Huh? Okay, practice well. Give tomorrow's exam. Don't miss. Okay. Okay. All right. Okay, Shreyuta, Samita, Xavier, all the best for your tomorrow's exam. We'll see you in tomorrow's class 6 p.m. Okay, every day now onwards.
Yes.
Okay. Bye bye. Take care.
Thank you, sir.